And welcome back. We're going to be looking at a new way of doing these derivative tangent problems. So far we've done it mostly manually where we draw the graph and then we draw the line. We make a kind of triangle here and count the change in x and the change in y. And then we get a manual version of the k-value of the tangent. But this time, we're going to be taking an algebraic approach. So here's the problem. We have y equals x squared minus 4, and that's a second degree curve. And we're going to look to the tangent that is attached when x is 2. And that's what this is. That's the x, and that's the y. So the first thing you need to do is think to yourself, well, how does this look? And either you use your calculator and draw the graph, or use the computer programs, or just draw it manually. Get a few points out there and then connect all the dots. I prefer the little graph program that I have on my computer. If you don't know what it is, just ask me. I'll show you how to get it. So here is the curve. That's what this is right here. Okay, now we're going to be looking for the tangent when x is 2. And that happens to be right there. So the tangent will then go through this point there. And again, I'll let the computer draw it because you know by now I can't draw. So here it is. There. Now the purple line is the tangent when x is 2. So how do we go about doing this? We know that y is x squared minus 4. And now we know how to take the derivative of these things. And it's a straightforward, nice little derivative. And now what we need to do algebraically is this. We're going to say when x is 2, what do we get? And that's what we'll put right there. So the general derivative for the whole curve is this first line. But now we're looking to when we have a specific case, and that's when we say y prime of 2. And then you take this general and you follow the formula. And now we know that x is 2, so it'll be 2 times 2, and that is 4. So we expect this purple line here to have a k-value, a slope of 4. Now, if you get a little confused about, well, wait a second, it seems to be going through the x-axis as well, and I'm just a little unsure, let me draw a few other tangents for you that have different values. Now, I'll take away the purple line and I'll put in 2 new ones. So here it is. When x is, for example, -1, that's this x right here, you go down and you look for the tangent, and it's this kind of turquoise line. So we don't have to calculate it. I just wanted to illustrate. Here is the one where when x is 1. Here's 1. You go down to the function. You look at where the tangent is, and then you'll see, okay, here's the tangent line. And obviously this one will be positive, and this one will have a negative slope, because you always look at it from left to right. Does it go up or does it go down, or is it flat? So if we were to calculate it, and this is just for fun now, it wasn't part of the original problem, but let's go back to this. Okay, x squared minus 4. So let's remember what we had here. If we have y equals x squared minus 4, then the general y prime would be 2x. Then we can take each one of these ones and look at it differently. I'll put the one over here. Y prime of -1 will then be, we'll follow the formula. It's going to be 2 times whatever x happens to be at that point. And in this case, it's -1. And that, of course, well, I don't have much room, but I'll put it over here. That'll be -2. So this turquoise line here, this one, will have a slope, a k-value, of negative 2. And over here on the right side, well, here's the formula again. So let's do y prime of 1, in other words, x is 1, that's the 1 right there, will be 2 times 1, just like we did the other side. So here's the general formula. This 2 is that 2. The x is the thing that we're choosing at a particular point. And of course, 2 times 1 is just 2. So this blue line should have a slope of 2, and the other one over here should have a slope of negative 2. Well, I hope that makes sense. We'll be doing some more. This is just part 1, so we'll take it one step at a time. We'll do some on the board too. All right, thanks.